Okay, so for Wednesday, our lesson is continuing to learn about the unit circle. So we'll probably do a practice unit circle in class, just putting in the degrees. So make sure that you do that, and then check it with a good one that you have filled out. Actually, I think we're going to put one in our composition book, but you're not going to have this handout because I can't find it electronically. But anyway, so first of all, find your little number 4 tab and start a contents page, table of contents for chapter 4. So chapter 4 is just titled trigonometry, and today's lesson is the unit circle, and then part of 4.1. So anytime you need to pause and catch up, please do so. If you have questions about anything, please send me an email. All right, so when you take your unit circle test, it's going to have a box at the bottom with some definitions. All right, these are the things that you need to know at the bottom of the unit circle test. You need to know the definition of the unit circle. So circle with a radius of 1 and a center at 0, 0, or the origin. You need to know the equation for the unit circle. And if you remember anything about the equation of a circle, then this should make some sense. It's centered at 0, 0, so there's nothing with the x and the y, and its radius is 1. So the equation of the unit circle is x squared plus y squared equals 1. A radian is the length of the radius measured about the circumference of the circle. A degree is 1/360th of a circle. And then sine, cosine, tangent, we will talk about later, but for right now, just write down that you need to know sine is the y coordinate, cosine is the x coordinate, and tangent is y divided by x. And we'll learn later on this week or after fall break why that is. Okay, so we are going to fill in a unit circle, and so I'm going to give everybody a blank one, and if I can find this digitally, I'll post it. You may have just a different version. I have one that I posted the other day. It just doesn't look quite like this one, but it has all the same blanks and stuff, so it'll work. You can just go back and print that one, another one of those. All right, so we are going to, I'm going to give everybody a blank one. They're going to fill in the degrees because those are easy. And then we're going to go through and do the radians together. And right now, we don't know the ordered pairs. When we learn those, we'll put them in there. So this is my composition book from last year because this is Sunday and I haven't taught this lesson yet, so I don't have this year's composition book. So you won't need to know these. You can go ahead and write them down right now if you want the whole thing filled in. But you won't get those until maybe Friday's lesson. So pause, fill in your degrees from memory. So pause, don't look at the screen, and fill in your degrees. And then check and see how you did. Then you can copy the radians. So remember, it's every other one. We count by sixths. So 1, 6, 2, 6, 3, 6, all the way around. And then the middle ones are fourths. So 1/4, 2/4, 3/4, 4/4. Keep going around. All right, again, ordered pairs, the only ones you should know are the quadrantals. The rest of those, leave them blank. We'll fill them in Friday. All right, so when you take the unit circle test, this page right here is important to you. All of this has to be filled in. Sorry, you can't see it. And you'll have a blank unit circle. You got to fill in all of that. Okay, so on to today's lesson. First of all, there's a lot of vocab we need to be straight on. All right, so lesson 4.1 on degrees and radian measures. We need to understand what's meant by initial side, terminal side, clockwise, counterclockwise, all of that. All right, so here are the definitions, and here's a picture where I kind of showed you what everything is. So the initial side is the starting position. That is going to be the positive x-axis unless otherwise stated. Terminal side is the ending position. So if I wanted this to be my angle, then this would be the terminal side. Counterclockwise are positive angles, and then clockwise are negative angles. All right, Standard position is the vertex is at the origin, the initial side, which is a ray, is on the positive x-axis. A quadrantal angle are the angles whose terminal side lies on an axis. So 0, 90, 180, 270, 360. All right, again, if I get to go in too fast, pause, catch up. All right, coterminal angles are angles that lie in the same place but have different rotations. So they're going to be a multiple of 360 degrees apart. So this particular angle that I drew here is at 135 if I just go straight there. But I could go backwards there and have a negative 315 as that angle. Or I could go all the way around the circle and back, and it would be 495. All right, so they're 360 apart. Negative 315 plus 360 is 135. 135 plus 360 is 495. I could keep adding or subtracting 360 forever and get an infinite amount of coterminal angles. Okay, so the first thing that we need to be able to do is, can we sketch an angle in standard position? All right, so if I ask you to sketch 135, you're going to draw an x and y axis, and you're going to put a ray where 135 is, and then you have to draw in the little arrow saying that I was going in the positive direction. Because if you just draw this, I don't know if you meant 135 or if you meant negative 315. All right, so negative 210. So going backwards, this would be negative 180. So a little bit past that, about 30 degrees past that, would be negative 210. And again, you've got to draw the arrow to show me where it's at. All right, 5 pi over 3. All right, I'm giving you ones that are on the unit circle right now. So you can look them up if you needed to, but you also need to start getting in the habit of, it's over 3, so I can count by 6 if I need to. So 1, 6, 2, 6, 3, 6, 4, 6, 5, 6, 6, 6, 7, 6, 8, 6, 9, 6, 10, 6 would be the same thing as 5 thirds. So that's my angle, and I went in the positive direction. All right, so determine the quadrants. All right, so 150. So remember, your quadrants are split where we have, let me grab a sheet of paper that I can write on. All right, so our quadrants are split where this is 90, 180, 270, 360. So 150 is obviously going to fall in here. So remember, this is quadrant 1, quadrant 2, quadrant 3, quadrant 4. So 150 is going to fall in quadrant 2. Negative 280. Well, if I go backwards, this is negative 90, negative 180, negative 270, negative 360. All right, it's also 0. That's what I just put there. All right, so negative 280 going backwards, negative 90, negative 180, negative 270, a little more between quadrant 1. All right, 400. That is more than 360. So if you need to, first of all, just say subtract 360. And so that's really looking at a 40-degree angle. So can you tell me where that is? Well, that's going to be somewhere about here. We went all the way around and a little more and landed about right there. So that's in quadrant 1. All right. So some more. All right, so let's say we have the angle 2,421. All right, so let's grab our handy dandy calculator. Any old calculator will do because we're not trying to do anything fancy. I just need to be able to subtract 360 a bunch of times. So keep subtracting 360. If you didn't know this calculator would do that, it will. Once you tell it to do the answer minus 360, if you just keep hitting enter, it's going to keep subtracting 360. And we're going to do that until we get inside the circle. And when I say inside the circle, I mean under 360 degrees. So we got down to 261. If we just keep subtracting 360, we're down to 261. So where is 261 on the unit circle? Well, 90, 180, 270, so 261 is in quadrant 3. All right, negative 100. Remember to go backwards if it's negative. So negative 90, negative 100 is going to fall like right in here. So that's quadrant 3. All right, what's this guy? 7 pi over 5. Okay, so I gave you a denominator that's not on the unit circle. All right, but this is what I want you to remember. This is 0. This is 1/2. So what's half of 5? About 2.5. So we write that as 2.5 over 5. This would be 1 pi, so 5 over 5. This would be a whole plus a half, so to add these, that's 7.5 over 5. All the way around is 2 pi, so 10 pi over 5. All right, so if I'm looking for 7 pi over 5, I'm a little smaller than this, so I'm going to be like right in here somewhere. So quadrant 3. All right. So trying these. So 11 pi over 12. So same thing. You've got to draw yourself a little picture using twelfths and figure out where you're going to land. So I said half is 6 twelfths, a whole is 12 twelfths, 11 twelfths falls in between those. So quadrant 2. All right, again, we got to do fifths. So we have this one. We're at 16, so that's more than 10. So if we keep going, this could be called 12.5, and this would be called 15, and this would be called 17.5. So 16 is going to fall in between those two. All right, and then this negative 12 sevenths. So I labeled, remember going backwards, half of 7 is 3.5, all of 7, all plus a half, so 7 plus 3.5 is 10.5. 2 sevenths would be 14. So remember we're going backwards. So negative 12 is going to be in between negative 10.5 and negative 14. So in quadrant 1. All right, and then negative pi over 3 is going to be right here. And if you need to write this like in thirds, this is 0, this is 1.5 is half of 3, so it'd be negative 1.5 over 3. Oh, you can't see that. Sorry. All right, so we know that negative 1 is going to be between 0 and negative 1.5. All right, we will do more of these. You will get better. And I know not being in the room, not being able to ask questions is tough. Please email me if you have questions, and I'll see what I can do to help. Okay, so next we want to be able to give one positive and one negative angle that are coterminal. So if you remember, we just wrote down coterminal means 360 degrees apart. All right, so if I'm asking you for one positive and one negative coterminal, you're going to take the angle, add 360, and take the angle, subtract 360. And that will usually get the job done. Unless your angle is more than 360, then, or less than negative 360, then you have to have a better plan. All right, and you don't have to do that to get one positive, one negative. That's just the fastest way. If you wanted to give me, like, subtract 360 4 times and give me whatever that one is, you wouldn't be wrong. You just did more work than you needed to do. All right, so we can add 360, we get 460. Subtract 360, we get negative 260. All right, for negative 30, add 360, you get 330. Subtract 360, you get negative 390. All right, so now let's try some in radians. All right, so all the way around the circle in radians is 2 pi. So we have to add 2 pi and subtract 2 pi. But you've got to make sure you have common denominators. So for thirds, 2 pi is 6 pi over 3. So I added 6 pi over 3 and I subtracted 6 pi over 3. All right, for 6, 2 pi is 12 pi over 6. So we added 12 pi over 6 and we subtracted 12 pi over 6. All right, so to convert from degrees to radians, we have these two little conversions. If I want to go from degrees to radians, I multiply by pi over 180. If I want to go from radians to degrees, I multiply by 180 over pi. Remember that pi radians is equal to 180 degrees. So since these two things are equal, multiplying by this is just multiplying by 1, but it's allowing you to cancel out what you don't want. So if I know degrees and I put 180 on the bottom, those degrees are going to cancel, and I just have radians left. If I know radians, if I put that on the bottom, then the radians are going to cancel, and I have degrees left. All right, I think we will maybe have a quiz on the 9th, so on Friday, over what we're learning Wednesday and Thursday. But we will see. We may wait and have it when we come back from fall break. We'll see. Just keep in mind there's a quiz coming. Okay, so now let's practice. Can you take these and write them in degrees? All right, so if I give you a radian, you're going to multiply by 180 over pi. I want degrees, so degrees needs to be on top. That's your thought process. All right, so showing the multiplication process for each of these. If I am giving you radians, you multiply by 180 over pi. The pi's cancel. So my calculator, I'm just doing 5 times 180 divided by 6. All right, same thing here, pi's cancel. So negative 14 times 180 divided by 15. This one doesn't have a pi because it's just negative 4 radians. On the unit circle, we only label the ones that have a pi, but there's all kinds of numbers of radians. You can find negative 4 radians, you can find 3.2 radians, whatever. So when you do this, the pi is still there. So you'll just do negative 4 times 180 divided by pi, and you'll get a weird little decimal answer. All right, so these are what our answers work out to be. All right, so going the other way, what if I want you to write it as a radian? Well, I gave you degrees. You want radians, so you're going to do radians over degrees for your multiplication factor. So we'll do pi over 180. All right, for these, we're just going to leave pi like it is because we like exact answers. That's why we do the pi ones on the unit circle. So I have 18 pi over 180, and then I can reduce. I have 870 pi over 180, and then I can reduce as necessary. All right, so that's it for today. That's all we're going to learn on Wednesday. Please send me questions that you have. Go back and watch it again and see if it makes any more sense the second time. But please email me and make sure that you are doing your assignment. There will be a practice unit circle attached for you to practice that, and there will be a worksheet for you to do some problems on.